More than 70% of the Earth's surface is covered by the oceans. About 90% of the ocean floor is made of sediments, which include grains of mud, sand, and gravel, which are constantly moved by the action of currents, tides, and waves. This apparently uninhabited environment, however, reveals an enormous diversity of life forms. A careful watcher may easily notice many species of animals, like crabs, hermit crabs, clams, and marine worms. But these relatively large animals are not alone in this place. In the tiny space between the sediment grains, there is a much more abundant and diverse fauna, invisible to the naked eye. They are small organisms, smaller than 1 millimeter, termed as Meiofauna.
Dos aspectos interessantes do estudo da meiofauna é que dos cerca de 35 a 40 filos animais descritos, cerca de 25 deles ocorrem nesse ambiente. Alguns passam seu ciclo de vida todo entre os grãos de areia ou sobre os grãos de areia, enquanto outros passam uma parte da vida na meiofauna e quando adultos vão fazer parte da macrofauna.
Para obter organismos meiofaunais, basta uma pequena quantidade de areia ou lama. Por exemplo, neste pequeno volume, podemos encontrar dezenas de espécies e milhares de organismos.
Once collected, the sediment is sieved through different mesh sizes, permitting the classification of the fauna into macrofauna and meiofauna. Specifically for the meiofauna, the material retained on the smaller mesh size is then observed under a stereo microscope. The organisms are picked up with micropipettes and transferred onto glass slides for examination at higher magnification. The observation of live material under the microscope allows us to see many of the essential morphological adaptations needed to inhabit and survive in this environment, an environment paradoxically large with many tiny interstitial spaces. For instance, in habitats subjected to strong water currents, where gravel, shell, and coral fragments prevail, some organisms attach to the grains. This life strategy allows them to capture suspended particles or prey upon other small animals without being dislodged by the water movement. Other species are modal and, when necessary, attach to the grains by means of adhesive structures, such as caudal glands, adhesive toes, and tactile setae. Others attach themselves by means of hooks. Or by muscular action and secretion of mucus. Armature to reinforce and protect the body from abrasion due to sediment agitation is another essential adaptation necessary to live in this dynamic environment. In habitats exposed to wave action, many organisms of different phyla have evolved a vermiform shape. Or are extremely agile. These adaptations allow them to move deeper into the sediment layers as a protection against the wave action. Another adaptation to live in this environment is the flattening of the body and the presence of ciliary bands for locomotion. These morphological adaptations permit the exploration of the labyrinth of the interstitial system and the surface of each grain of sand. In sheltered environments like bays and estuaries, wave action and currents are weaker. This facilitates the deposition of fine particles and detritus. In response to these high levels of organic matter, life in these habitats is abundant. Due to the fine sediments, the interstitial space is reduced, demanding organisms to be relatively robust burrowers or gliders, which can move within this fine sediment. By consuming detritus and being consumed by larger animals, the Meiofauna plays a significant role in the recycling of organic matter and is an important component in marine food webs. In addition to its ecological importance, the Meiofauna is a valuable tool to assess the sensitivity of marine ecosystems to anthropogenic changes.
Diferente dos organismos maiores da macrofauna, a meiofauna possui ciclo de vida curto, sem estágio larval planctônico, de modo que todos os seus estágios de vida estão intimamente associados aos sedimentos, onde a maioria dos contaminantes fica acumulada. Além disso, as altas densidades e grande número de espécies encontradas em um pequeno volume de sedimento permitem a manipulação de comunidades naturais em laboratório de forma relativamente simples. Assim, podemos avaliar os efeitos de diferentes tipos de contaminantes liberados no ambiente marinho.
Today, approximately 15,000 Meiofauna species are described. It is estimated that the real number could be 100 times higher, as only a small fraction of the ocean floor has been studied. There are still many discoveries to be made, and much to learn with these microscopic organisms. Many generations will be necessary to fully comprehend the complexity of the life between grains.